Athnos is going to be presenting today a topic which should be near and dear to all of our paper-making hearts, and that is the correlation between, sensors as well as QCS lab instruments. So for the quality lab, her topic title is Bridging the Gap Between QCS and Gauging Systems. Lou Athnos has not one, but two master's degrees from the great school of NC State in paper science, one in paper science and one as an MBA. So congrats to Lou, the overachiever. Lou has been working in a technical role with ABB since 1996. And as a systems engineer working on QCS, regional technical advisor, and with the QCS technical team. Today, Lou serves as our account manager covering the Midwest region, which she has quickly excelled to be top of the pack. So all of you other account managers out there, you're hearing a presentation today from the head of the pack in our account managers by sales volume this year. So she brings over 20 years of process control expertise in the paper making industry. With that, she chairs the Sensor and Correlation Common Interest Group with the TAPPI Process Controls Division. And she will be presenting this same presentation to our customers as part of TAPPICon. So without further ado, I'll hand the mic over to Lou, and thank you.
Thank you, Jonathan, for the wonderful introduction. During this session, I will be talking about a few important subjects related to sensor correlation. This is a comparison between the QCS gauging systems and quality labs. So we all know that if you have two watches, you don't know what the right time is. So proper sensor correlation ensures your QCS online sensors read accurately. So the presentation, I'll be using the term of QCS gauging systems and online sensors. That's what I'm talking about, the same thing here. So we often hear about discrepancies between the two, and there always seems a gap between the two. So during today's presentation, I will be talking about what is this gap and what are the main contributors to this gap. And I will provide a few examples that create the gap that's commonly seen in old paper mills. Of course, I'll talk about best practices to bridge this gap. I'll talk about a problem and suggest a solution. And then at the end, I will introduce a technical information paper that our sensor correlation common interest group produced. That's on dynamic sensor correlation sampling method. So let's dive in. When we look at the deviation between the online sensors and the lab, that mainly comes from three areas: the sensor accuracy, the process variations, and the lab test accuracy. So the total variabilities from all three areas will impact the sensor correlation results. So for example, the online sensor, is it calibrated? Is it accurate? Is it repeatable? And I'll get into more details later on. How about the paper making process? Does the process have a high machine direction or cross machine direction variability? And then let's take a look at the lab. I see a lot of smiling faces at this time, I think, because a lot of people, they know that there's a lot of discrepancies in the lab testing procedure. Are they following the TAPPI standards? Do they even have a standard operating procedures for the lab testers? How about correlation methods for the different paper properties? Are they using single point, for the different paper properties? Are they using real weight or roll weight for the basis weight? How are they dealing with the mid-machine scanner measurements? So there's a lot of challenges with the lab tests. And how about the lab equipment? Are they even calibrated? So these are the main three areas that will impact the sensor correlation results, which means they will create the gap. Okay, let's take a look at a few examples that will create this gap. First, let's take a look at this online sensor accuracy. So still many people confuse the terms between sensor calibration with sensor correlation. So it's important to differentiate between the two terms. I always like to define the terms. So calibration is a comparison between a known measurement, which is a calibration standard, and the measurement using your instrument. This is a definition for calibration. So you just want to measure the input from a standard source. Then you control the output so that the signal being output is accurate and repeatable. Calibration actually has little or no association with measuring a specific paper maker's product. I know you think this is crazy. So for example, the calibration of a basis weight sensor, it compares its response to the Mylar sample standards. Once the relationship between the basis weight sensor response and the standards is known, the calibration process is complete. For example, let's take a look at this example that shows the basis weight calibration results. The x-axis shows the range of the sample weight. The red line here shows the deviation between the sensor measurement and the calibration standard. And the blue lines here, that's the limits of the calibration. So the chart on the left shows a calibrated sensor because the deviation falls within the calibration limits. But the one on the right is also a true example that shows this is an uncalibrated sensor because your deviation between the measurement and the standard that falls outside of the limit. So it's important to make sure the sensor, the online sensor is calibrated first. And calibration should be done before correlation. And also, I want you to know that a calibrated sensor doesn't mean it's a correlated sensor. Next, let's take a look at the process. Many mills use the single point dynamic correlation method to correlate the online sensors with the lab. So let's take a look at the trend on the right here. This is a moisture machine direction variation. It goes from 6.6% to almost 8%. So depending on the single point sampling location and the sample size, it's very hard to measure and collect the samples in the same area of the reel, which really means your lab sample may not be able to capture the same location that the online moisture sensor measures. So you may be comparing apples with oranges when you do the correlation. Then you wonder why the lab test results don't match the online sensor. Let's get into the fun part and take a look at the lab test. First, let's take a look at the instrument accuracy. So here is a true example showing where the lab test error came from. So a few months ago, I was contacted by a process engineer at a mill. He showed me some scanner versus lab data for basis weight and moisture, and he needed help evaluating their sensor correlation results. He felt that something was just not right. Since I wasn't able to visit this site auditing the lab test procedure, so I just asked him to describe how they test the basis weight in the lab. You think about it, basis weight, the definition is weight per unit area. So you just got to look at, okay, weight, and you use a scale. And then the area, okay, he uses a die cutter, as you can see in this picture, to cut a sample, weight on a scale. Then I just gave him some suggestions to look at his die cutter and then to look at his scale. So he sent me a picture of his die cutter along with this product brochure, and I took a screenshot of it. So as you can see that it's advertised as a 12 by 12 inch sample cut, which in our mind is 12.0 inches by 12.0 inches in size, which means the area should have been 144 square inches. So then I got some feedback from this process engineer. He literally took the measurement of the die cutter area. So he actually measured the sample size to be 11.897 inches by 11.957 inches. This means the true area of this die cutter cut is 142.1 square inches instead of 144.0 square inches. You just can't take anything for granted when it comes to sensor correlation. So what does that mean in terms of calculated basis weight result if the area was wrong? So for this particular grade, the sample weighs 14.8 grams. So when you calculate to GSM or pounds per ream, the error here is 1.9 pounds or 2.09 grams here. So the actual basis weight was actually heavier than the falsely calculated base weight. So this is really bad news for a paper maker. If they correlated the online basis weight sensor with this false lab test result, they could be rejecting off-spec paper that was really in spec. And they also wasted fiber and energy to produce the actual weight that was not accounted for. So we can calculate it in dollars, and this could be great loss for the mill. This is a true example. Okay, let's take a look at more lab procedures. And this is the one that I saw with my own eyes. This mill had a scale on the table right on the machine floor. And they had actually a glass protector, as you can see here. And they actually cut weight samples with 4 inches in diameter and put it on the scale. If you just touch the table with your hands, the scale reading changes, as you can see here. Just varies so much. Or if you just blow air, even if you just breathe a little hard, that scale reading changes. So think about that little sample they use, a 4-inch in diameter weight sample. And if your scale is off, when you calculate your basis weight result, that could be very different compared with a true basis weight value. And then this last one, at least he protected the samples in a Ziploc bag, and he is going to do the moisture sample test. But if you take a look at how he put the bag on the scale, it's actually the bag is touching the base of the scale, which means the weight will not be accurate. All of these errors just add up, and they create that gap between your online sensors and the quality lab. All right, let's take a look at the paper drying process when it comes to moisture lab tests. So, the lab moisture results are being affected by the oven conditions, the temperature, and the drying time. Are they cooking pizza in that drying oven, roasting peanuts? I've seen them myself. How about the temperature of the oven? Is it set at 105 degrees Celsius, not Fahrenheit? How about enough drying time for the paper samples? Oh, this is a good one. The chart on the right was a study showing the relationship between paper drying time versus the sample weight and the calculated moisture. So the x-axis is the drying time. The blue line shows the sample weight drop as time goes on, and then this orange line shows that calculated moisture. So, the weight kept dropping until it reached bone dry weight, no more moisture loss. And that's when you calculate the accurate moisture. So it's important to determine this minimum drying time. Some mills, they just ask me, Lou, how long should I dry my paper? And it's like, depends. You got to do your test to determine your minimum drying time. Make sure you get to bone dry weight. And then, you got rid of all the moisture, then you can calculate an accurate moisture. And some mills, they just use a set drying time, like 60 minutes. I asked them, I said, why do you only dry the samples for 60 minutes? If you got to the bone dry, the answer is we've always done it this way. So we looked at the 3 different areas that can create this gap. When you think about sensor correlation, how do you set the realistic expectations? For the deviation between the lab and the online sensor, what is achievable? And when do you need to make a correlation change? Should it be off by half a pound, 1 pound, 2 pounds? Moisture, is it 0.5%? So what's achievable? And how do you objectively determine this expectation? So you really need to investigate the variabilities in all 3 areas to determine the limits. Okay, this is not something you can just grab. You have to do some calculation and objectively determine this limit. I have spent some time discussing the problems, the causes of this gap. That leads us into this solution. There's many best practices the paper makers can do to bridge this gap. Verify the QCS scanners and the online sensors. So you got to make sure the scanner alignment is properly set up in the machine direction and the cross machine directions. You got to make sure all your online sensors are properly calibrated and to make sure they are repeatable. Then the next one, you need to reduce your machine direction and cross machine direction variability, because we know that will affect your lab test result. The lab's instruments have to be calibrated to a traceable standard, such as the NIST, that's the National Institute of Standard and Technology. So just like the online sensor, the lab instruments have to be calibrated. I just talked about the calculate proper correlation expectations. You got to look at all three different areas to determine what's the realistic limits, because just doing sensor correlation without establishing the limit is not acceptable. You must determine proper expectations. You got to select correct correlation method for each online sensor. I mentioned a few ways of doing the online sensor. So for example, if it's tissue paper, you want to determine the basis weight of tissue paper. It's hard to use a single point method because then you cut one area of the paper. Tissue has its elasticity, so it's very hard to determine an accurate area, which leads to the inaccurate basis weight calculation. So it's the best to use a real weight or a roll weight method for the basis weight of the tissue paper. Set up standard operating procedures for the lab testers. And nowadays many backtenders work in the lab as well. And you got to inspect what you expect. Make sure they're following all the proper procedures. And then use a large sample set to reduce the effect of random lab and sampling errors. For example, for moisture correlation, we recommend that you need to collect at least 100 grams of samples. You don't want to just have a really small sample, then that will definitely increase the error of your final lab test results. Conduct correct correlation analysis by performing a two-variable regression. Many people know about doing a two-variable regression. I just need to calculate a slope and offset. But it's not just that simple. You need to understand that the lab result needs to be treated as the independent variable, and it needs to be put on the x-axis when you do the two-variable regression. And then the sensor reading is the dependent variable, and it needs to be on the y-axis. I will introduce a book to you if you want to learn a little more about this, two-variable regression. The sensor correlation should be an ongoing process. It's not a one-time deal. You do it and you forget about it. Things change. The online sensor is being influenced by the environment, like the source decay for the basis weight, the paper process furnace changes. So you always need the offline lab to correct the online sensor measurements. Because sensor correlation gives us a system of checks and balances. It validates the slope and offset in the product code. So it needs to be an ongoing process. So these are the main best practices to bridge the gap to get good quality sensor correlation. And I talk about telling you about a book. If you want to learn more about sensor calibration and correlation, I would suggest this wonderful book published by TAPPI, Paper Machine Quality Control Systems, Volume 1. The team is actually working on Volume 2 of this book. Earlier, as Jonathan introduced me, I'm the working chair for the Sensor Correlation Common Interest Group, which is part of the Process Control Division. So we have a mission. Our mission is to create and promote principles and best practices regarding sensor correlation. So our goal is to put paper mills on the right path to success by ensuring measurements from the online sensors and the offline quality measurement closely track each other. As of the end of 2021, we have published this technical information paper on QCS dynamic correlation sampling method. This procedure applies to all of the QCS vendors. It's not vendor specific. In this tip, we cover the materials and equipment needed and how do you prepare for the test and a detailed correlation sampling procedure. Because single point, it literally applies to all different paper properties. So after this, our next one we're working on right now is the moisture correlation method. And we are going to be expanding that to the other sensors. But as we're, right now, we feel moisture is definitely a very challenging one to correlate. So that's a procedure we're working on. We are getting close to get that finished, and then we'll get that published. So let's just summarize real quick. In this session, I have talked about the gap between the QCS gauging system and the lab. We talk about, what causes the lab and provided some examples. And then, of course, the best practices to bridge this gap. If you have any questions, please feel free to contact me and any questions. This is the time we open to
All
the
right. Well,
floor
thank
and
you.
people can ask questions.
Lou, since ABB is a supplier of both QCS and lab equipment, it's only natural that you would tie those two together. What's ABB offer for that?
Always using the lab as your standard and correlate the QCS with the lab.
How do you
So
automate that?
we had a couple discussions about automating it, but I personally see a lot of challenges automating that. For example, moisture. Are we properly protecting the samples after they're taken from the reel? Like using our auto line. Are we following the TAPPI procedures? There's going to be a challenge. There's certain paper properties we can automate using the auto line and feeding the data right to the QCS. I think there is a project being worked on by a team in ABB, but definitely not for every paper property. So, if you ask me how to do it, definitely certain properties you can do, maybe some surface properties, but then with the QCS scanner, we really need to do a good job comparing apples with apples. I still think there's going to be a challenge.
I have a question for you.
Okay, Steve.
As far as the auto line is concerned, we have a reporting mechanism that can go back to the operators. How do we tie that into bridging this gap?
I always say, because trust me, I've had this conversation with over 2 years ago. My concern is always, okay, we get the data, but how do you know it's good data? You have to follow all the proper procedures, the best practices to do the correlation properly, to give us the data. Then we can automate this correlation. But if we don't know if your data is good, we might be in danger. How do we correlate something with that? So to me, that prerequisite is more important than automating everything. It's a good idea, but that prerequisite is so important.
So what you're saying is garbage in, garbage out.
Absolutely.
Can you recap what's the biggest challenge customers face in not doing this properly? Why don't they all do it?
People is a big thing. Not having enough people to do this. They don't realize the importance of correlation. So many of them, they still do the sell by gauge and they think, I got a scanner, it's good to go. Don't need to do the correlation to validate it. So that's one thing, not realizing it's important to do this process. Number two is the people and the cost. We see so many mills, they eliminated the quality lab. So they just do the bare minimum. And then the quality of their test results and the quality of the data they provide to us. Pretty much every mill I've been to, if they ask me to audit the sense of correlation, if they have a program, and I audit their procedure, I just follow the lab tester to see what they do. And I find all kinds of problems with it. And they always tell me, we've always done it this way. I can show this tip we created, published. When they use single point, some of the mills, they always use the same spot, the exact same spot. They even draw a line on the floor. That's our single point spot. But that spot can be a high spot and a low spot. This may not truly represent your quality data. And also, they don't protect the samples, just all kinds of problems in their data sampling process. One thing I always tell our guys, sense of correlation effort, if we're doing it in the mill, should always be a joint effort. Should not be only ABB's responsibility. This is from a liability perspective. So, people can't argue with good, accurate data. You really just have to point out these discrepancies, like for basis weight, do you have the trim width set up correctly? Do you have the linear finish? Is that accurate? Is the scale calibrated? So there's so many variables, and you just need to find out where the discrepancies are. But you just have to show them the standard and point out, cannot take anything for granted, because everything has to be accurate for us to get good results. If the data is not good, the process is not good, we've seen that this is definitely a challenge.
Lou, I just wanted to express my thank you for going above and beyond the call of the normal account manager responsibilities and representing ABB so well at what's the most important conference we have in our industries.
Thank you all.